All right, and these last two examples from this section, these are not set up to be able to use the power rule. Right? I've got two different binomials being multiplied together here, and then in the last one I've got two different things being divided. So what I can do before I take the derivative using the power rule is multiply this out. All right, so I can multiply x times 2x, get 2x squared, x times negative 4 would be negative 4x, 3 times 2x would be 6x, and 3 times negative 4 would be negative 12. So that would just become 2x squared plus 2x minus 12. So now I can take the derivative. Okay, I can use the power rule to take the derivative of each individual piece. Now, I could not use the power rule to take the derivative of each individual piece as this is set up because we have two different polynomials being multiplied together. I would have to multiply it out like this and then take the derivative. Okay, so now the derivative is equal to, so I can use the power rule here and say this would be 4x plus 2. Okay, make sure that if we have something like this where we have multiple polynomials being multiplied or divided, we cannot use the power rule on each individual piece. We would have to have it set up so that all we are doing is adding or subtracting terms. Okay, I cannot be multiplying terms together like this. All right, so similarly down here in F, I can rewrite this. So I can split this up. Since I'm just dividing by a single term, I can just write this as 8x cubed over x plus 4x squared over x minus 3 over x, and then I can simplify each individual term. So this would just become 8x squared, this would become 4x, and this would become minus 3x to the negative first. So now I can take the derivative. Okay, and as you're going through, be careful where you're putting equal signs and things like that. So we just simplified my original function, okay? But now I am creating a new function. I'm creating the derivative. So make sure that you don't just put like an equal sign here and then write the derivative. Okay, make sure that you specify that this is a new function. This is the derivative function, right? So I'm saying now the derivative would equal 16x plus 4. So then bring this negative 1 down. So that would be negative times a negative would be plus 3x to the negative second. Okay, and we can leave our derivative answer just like that. All right, now the last problem on here is finding the tangent and normal lines to a curve. Okay, tangent and normal. So tangent, remember we said just touches the curve at one spot and estimates the slope at that point. A normal line is just a line perpendicular at a certain point. Okay, well, in order to, let's first write the tangent line. Okay, in order to write a tangent line, I need two things. I need a point on the curve, and I need the slope at that point. Okay, so first, let's get the entire point at x equals 2. Right? To do that, I would just plug 2 into my original function. And I can say y of 2 would be equal to 2 times 2 cubed minus 2 plus 1. So that would be 8, 16, minus 2 is 14, plus 1 is 15. So the point that I'm going to be working with is 215. That is the point on my original curve. Okay, so now to get the slope, what I want to do is take the derivative. So I can use power rule now to take the derivative. Okay, so let's do y prime. Well, yeah, let's just write it as y prime. So y prime will be, bring the 3 down, so that would be 6x squared minus 1 plus 0, because the derivative of a constant is 0. And now I can evaluate y prime of 2. Okay, I found the y value at 2. Now I want the slope at 2. So I'm just going to plug 2 in here. So that would be 24 minus 1 is 23. So that is a pretty steep slope, right? A slope of 23. So I have the information that I need now to write the equation of a tangent line. I know that the slope at this point is 23, and I know the point that this goes through. So I'm going to write y minus y1 equals m times x minus x1, and just plug this in. So I will have y minus 15 equals 23 times x minus 2. So this would be the equation of the line that is tangent to the curve at the point 215. Okay. Now we also want to write the normal line. So let's label this. This is the tangent line. Now the normal line, all I'm going to do is take the perpendicular slope. So the perpendicular slope to 23, the opposite reciprocal slope would just be negative 1 over 23. So the normal line, it's going to go through the exact same point. It's just going to have the opposite reciprocal slope. So the normal line will be y minus 15 equals negative 1 over 23 times x minus 2. All right. So and we said we could leave our answers just like this. You don't need to simplify to put it in slope-intercept form unless the directions specifically say, but for most of what we do, we can just leave our answer just like this. All right, so that is it. There is a homework posted with a few problems that I want you to practice, so go ahead and try those now.